welcome once again. So we are back with a new chapter of statistics. So this is chapter number 16 from our study material, which is theoretical distribution, also known as probability distribution. So welcome everyone once again, and let's see who all are live with us now. Akhilandeshwari is there, Pramod, Shreya Tiwari, Ananya Kumari, Ruchika, Dimple, Soumya Rajan, Nikita, Bharat Chaudhary, Tamanna, Surya Kumari, Arpisha, and Shruti Pathak. So, very good afternoon, everybody. So, let us begin with the interesting chapter. First of all, we will talk about the weightage of the chapter. Normally, 4 to 5 questions come from this chapter. So, this chapter is again very important. And this is basically an easy kind of chapter, not much difficult. There are 3 basic formats which we have to go through in this chapter. Okay. So some more people are live now. Shri Pran, Lisa Jain, Sarvesh, Manish, Ritu Tiwari, Samina Hakim, then Tina Verma, Shakti Singh, Tanmeet Kaur, Shreya Modi, Mehak Roy, Swati Giri, Manisha Rashtroy. Great. So good to see you once again, guys. So this chapter is theoretical distribution, also known as probability distribution. This chapter is basically the extension of the chapter probability. Probability का ये extension है. So mainly we divide this chapter into 2 portions. The first portion is known as discrete probability distribution, and second one is continuous probability distribution. So this chapter is divided into 2 parts. One is discrete, other is continuous. Under discrete distribution, we are having mainly 2 distributions. One is binomial distribution, other one is Poisson distribution. One is binomial, other one is Poisson. So we will cover this in detail. So binomial distribution will be covered today in detail, and Poisson will be covered in the second lecture of this class, which is on Thursday. Then comes continuous distribution. So continuous is having normal distribution. So there are other kind of distribution as well, which are continuous, but they are not in our syllabus. So let me write the name. One is chi-square distribution. Then other is T distribution. And last one is F distribution. These are basically all continuous probability distribution, but all these are not in our syllabus. We have to do basically normal distribution. So we will cover this topic on Saturday, that is 11th. Poisson will be covered on Thursday, and binomial we are covering today. Okay. Perfect. Now we have to start with this. Now, why theoretical probability distribution is used and why the name is theoretical probability or theoretical distribution. So let's say we are tossing coin for 100 times. We are tossing coin 100 times. Then how many times head will appear and how many times tail will appear? Out of 100, how many times heads will come and how many times tail will come? This you have to answer. So what will be the answer? So we know that the probability of getting head is 1 by 2 and probability of getting tail is also 1 by 2. But we don't require probability here. We require the frequency. कितनी बार heads आएगा and कितनी बार tails आएगा. हमें उसकी frequency चाहिए, number चाहिए. So how to calculate that? So frequency is equal to n multiplied by the probability. N multiplied by the probability. So what is n? Number of times we are tossing a coin. Number of times the experiment is repeated. So 100 multiplied by. Now what is the probability of getting head? It is half. So result is 50. So we can write 50 times head will come. And similarly, tail will also come 50 times. So Dimple has given the answer 50, 50. Yes. So 50 times heads and 50 times tails. Similarly, let's take one more example. So this time we are throwing a dice for 30 times. Now, how many times number 1 will come on the dice? How many times the number 1 will come on the dice? So for frequency, it is n multiplied by the probability. So what is the probability of getting number 1 on the dice? It is simply 1 by 6. So we will answer 5. So number 1 will come 5 times. Similarly, number 2, how many times it will come? It will come 5 times, and so on. So in this way, we can easily calculate theoretical distribution. All right. So this is a basic concept. So now let us continue with some of the theories. Yeah. So let us begin with some of the basic characteristics, basic features of binomial distribution. One of the most important and frequently used discrete probability distribution is the binomial distribution. So among the two discrete distribution, this one is most important. This one is of major use as compared to Poisson. So this is frequently used. It is derived from the particular type of random experiment which is known as Bernoulli process, named after Jacob Bernoulli. So this can also be regarded as Bernoulli's theorem. This can also be regarded as Bernoulli's theorem. Now, here we know that there are few terms which we use in probability. The first term is trial. The first term used is trial. Now, what is the meaning of the term trial? Trial means an experiment which we are doing. An experiment which we are doing n number of times. That is basically a trial. So here we will write that there are n number of trials. There are n number of trials, and all these outcomes which happens are mutually exclusive and exhaustive. So each trial is associated with two mutually exclusive and exhaustive outcomes. So we have already done this. Like whenever there are two outcomes, one is success, other one is failure. One outcome is success, other outcome is failure. And they are exhaustive. That means their sum of probability is equal to 1. Sum of probability is equal to 1. So let's write here, there are n number of trials and this n must be positive. Now, number of trials is always positive. That is, it will be number 2, 5, 10. We cannot write -3 because we cannot toss a coin -3 times. We cannot throw a dice -2 times. So always the number of trials will be positive. Then it will be a whole number, or we can say it is an integer value, or we can say positive integer value. So it will not be a decimal. That is 1.1 is not possible, 1.4 is not possible, because all these trials are either 1 or 2 or 3 and so on. So they cannot appear in decimals. Then we say that events must be independent of each other. They must be independent of each other. Then there are two outcomes. One is success and other is failure. So probability of success is denoted by P and probability of failure is denoted by Q. And their sum. The sum is always taken as 1. So P plus Q is equal to 1. So we can write P is equal to 1 minus Q, or we can also write Q is equal to 1 minus P. So this is the basic condition of binomial distribution. So these are the basic conditions of binomial distribution. So let us recall. What is the first condition? There are n number of trials and the trial must be positive. It must have an integer value, that is, it should not be a decimal number. Also, it is always a finite value. It is always a finite value. It cannot be infinite. Second thing is independent. They are independent of each other. So either success will happen or failure. Head will come or tail will come. So they are independent. Then the two outcomes are named as success and then failure. Success is denoted by P, failure is denoted by Q. Then the fourth one is the sum of their probability is equal to 1. So P plus Q is equal to 1, or we can say that P is equal to 1 minus Q, or Q is equal to 1 minus P. So these are the basic conditions for binomial distribution. All right. So let's move forward. So this we have done. Now it is denoted by this. Now what is the meaning of X? Then there is a symbol P and in bracket n comma P is written. So it says that X follows. It means that X follows B is binomial distribution with parameters n and p. So what is the language? X follows binomial distribution with parameter n comma p. Now what are the parameters? Parameters means those values because of which we can calculate anything. If you want to calculate mean, if you want to calculate standard deviation, variance or probability, everything you can calculate with the help of these two values. तो इन दोनों वैल्यूज से हम सब कुछ कैलकुलेट कर सकते हैं, इसलिए इन दोनों को कहा जाता है पैरामीटर. ओके, पैरामीटर ऐसी चीज है जिसकी हेल्प से आप कुछ भी कैलकुलेट कर सकते हैं. So let us write some of the formulas for binomial distribution. The first formula is for mean. The formula for mean, that is mu, is equal to n into p. Formula is very easy. It's very short. इतना छोटा है कि शुरू होते ही खत्म हो जाएगा आपका formula. So mean denoted by mu is equal to n comma n multiplied by p. Second formula is variance. Second formula is variance. Now the formula for variance is NPQ. NPQ. The third formula is standard deviation. It becomes root of NPQ. The square root of NPQ. And then the fourth one, probability of X. It is equal to NCX, P to the power of X and Q to the power of N minus X. So this becomes the formula for the probability in case of binomial distribution. Okay. So now you have to remember these four basic formula, and these are very easy. Now from this, what is small n? Small n is basically number of trials. It is number of trials. Then P. P denotes probability of success. Then Q. Q denotes probability of failure. And what is X? X is the required number. X is the required number. Whatever you have to calculate, that we can write in. So to understand this, let us take one basic example. So let's take an example of coin. 6 coins are tossed. 6 coins are tossed. What is the probability? What is the probability of getting 2 heads? What is the probability of getting 2 heads? Now, this question can also be done using the previous chapter, that is the probability. If we try to solve this using probability, then we have to form some cases. So how many cases will be formed? 2 to the power of 6, that is 64 cases will be there. So that's why that concept, that logic will become very lengthy. So in order to calculate in like fast manner, we can use this binomial distribution. Okay, we'll get the same answer, but this method is much easier. So to calculate this, we have to find 4 values. What are the 4 values? N, X, P, and Q. N is number of trials. So how many times we are tossing the coin? 6 times. Then what is the required number? 2 heads. So X is equal to 2. Then P denotes success. So when success will come? When head is appearing. If head comes on the coin, then it is success. So it will be 1 upon 2. And then failure will be 1 by 2. Failure will be 1 upon 2. So let's calculate this. According to formula, it is NCX, so 6C2, P to the power of X, that is 2, and Q to the power of N minus X, so 6 minus 2. It will become 6 into 5 upon 2 into 1 multiplied by 1 by 2 whole to the power of 6. So 15 upon 64. This becomes your answer. So any doubt till here, let me know. Any doubt till here, let me know, because this is the basic concept of binomial distribution, and in this way we can calculate the probability. And after that, you have to solve. All other things are same. Just you have to find what will be the probability of getting 3 heads when 6 coins are tossed. So what will be the probability of getting 3 heads? This we have to solve. Come on, everybody. I'm waiting for your response. It's very easy portion basically. So if you have the knowledge of solving combination, then you can easily do this. So Dimple has given the answer. Manish has also given. Ruchika. Why 6 into 5? Yes, Ruchika, if you don't remember combination, you have to go through that first, because it is the shortcut way of solving 6C2. 6 into 5 upon 2 into 1. Okay. So this time we are having 3 heads. So first step is always write all the values. N is 6, X is 3, P is half, and Q is also half. So 63, 1 by 2 to the power of 3, and 1 by 2 to the power of 6 minus 3. So it will become 6 into 5 into 4 upon 3 into 2 into 1. So 6 and 6 got cancelled. What is left? 20 upon 64. 20 upon 64, this becomes the answer. Okay. All right. Now, in the same question, we are solving the third portion. What is the probability of getting 5 heads? 5 heads. So again, it will be, now you can easily solve 65, 1 by 2 to the power of 5, and 1 by 2 to the power of 6 minus 5, which is 1. And what is 65? It is 6 upon 64. So 3 by 32 becomes your answer. 3 by 32 becomes the final answer. Okay. Now, the fourth question, what if the question is talking about at least 5 heads? At least 5 heads. So what will be the values? N, X, P, Q. So rest all are same. 6 coins, half P, half Q. But what will be the value of X? So at least 5 heads are required. कम से कम 5 heads चाहिए. तो 5 या उससे ज्यादा हमें select करना पड़ेगा. So we will take 5, 6. Because more than 6 is not possible because maximum number of coins are 6. Now we can solve this and get the result. So we will write probability of x equal to 5 plus probability of x equal to 6. So we can solve this into two parts. So let's write 65, 1 by 2 to the power of 5 and 1 by 2 to the power of 1 plus 66, 1 by 2 to the power of 6 and 1 by 2 to the power of 0. So what is left? 6 by 64 plus 1 by 64. It becomes 7 by 64. So this becomes the final answer. Okay. So Ch-16 says got it. Tanmeet has given the answer. Dimple has given. Manish has given. Great. Perfect. Alpit Thankar has also given the answer. Okay, great. So I think you have understood this concept. Now let me take one or two more. Question number 5. What is the probability of getting this time at most two heads? At most two heads. Then what we have to do? So in this case, what will be the x? X is at most two, means maximum two heads, not more than two. Maximum two heads. So we can take 0 heads, 1 heads, and 2 heads. So in this way, we have to solve. So probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. So these become the three parts. Now we can simplify this and get the result. 6 is 0, 1 by 2 to the power of. Now you can see that the whole power is basically always 6. So you can directly write 6. Because P and Q are same, so their sum of powers will always be equal to n. Like 5 plus 1 is 6, 6 plus 0 is equal to 6. So always the power will be, the sum of powers will be equal to n. Then you can write 61, 1 by 2 to the power of 6 and 62, 1 by 2 to the power of 6. Now 1 by 2 to the power of 6, you can take common. What is left? 60 is 1, 61 is 6, 62. 62 is how much? 15. So what will be the total? 15 plus 7 is 22 upon 64. 22 upon 64. This becomes the final answer. Okay. Understood? Then Navin is asking about the previous one. How 5 and 6? So you have to go through with the language. The language says at least 5. कम से कम 5. 5 से कम में तो जाना ही नहीं है. 5 या उससे ज्यादा. So you have to select 5, 6. And 6 से ज्यादा is not possible because maximum number of points are 6 only. Therefore, we have to restrict till 6. Okay, Navin? So Shreya has given the answer 11 by 32. Okay. Then Manish has also given the answer. Alpit Uncle, Dimple, Nikita. Great. So this time everyone is correct. Now the last portion, that is probability of getting at least one, at least one head. Now, at least one head means what? एक head तो आना ही चाहिए. So what will be the value of x? X will be 1, 2, 3, 4, 5, 6. So according to this, it will become very lengthy because we have to take x equal to 1, then we will take x equal to 2, and so on. Up to we have to take x equal to 6. So it becomes very, very lengthy. So how to make it short? So in order to make it short, there is one shortcut formula which we have already discussed in the previous topic. Whenever at least one is written, what you have to do? 1 minus probability of none. Whenever at least one is written, what is the shortcut? 1 minus probability of none. Now, what is the meaning of none? None is x equal to 0. So 1 minus probability x equal to 0. So you can solve 6 is 0 and 1 by 2 to the power of 6. So what will be the answer? 63 upon 64. 63 upon 64. Okay. So in the case of at least one, this is the shortcut method which you can follow. Okay. Now, any doubt till here, let me know. Otherwise, we will proceed to the next question. So everybody is giving the answer. That's great. Good going, everybody. So let's move. Now there is one additive property and one more property of variance. Let's understand that. Now, whenever we are talking about the formula, so we are having one is mean and other one is variance. Mean and variance. These two are here. Now we know the formula for mean and variance. So what is the formula for mean? The formula for mean is n multiplied by p. And what is the formula for variance? It is npq. npq. So mean is np, variance is npq. So which is greater in case of binomial distribution? So many theoretical questions come from this chapter. So you have to be careful in theory as well. But theory is very, very easy, not difficult. So which one will be greater, mean or variance? Let me know. Formula for mean is NP and formula for variance is NPQ. So कौन सा बड़ा होगा? Which one is greater? So we can take one example also. So let's say we are tossing 20 coins, and what is the probability of getting head? So head denotes success. So its chances are 1 by 2, and Q denotes failure. So its chances are also 1 by 2. 1 by 2. Now apply the formula and see. Money says variance is greater. Dimple says mean is greater. Let's see. So if we apply the formula for mean, it will be 20 into half. That is 10. Whereas in variance, 20 into half becomes 5. Now, which is greater? Mean is greater. Mean is greater. So we have to remember this always in case of binomial distribution, mean is greater than variance. Okay. Then the next thing is, what is the maximum value of variance? What is the maximum value of variance? So maximum value will occur when P and Q both are equal. When P and Q both are equal. And when they are equal, when the value is half, or you can say 0.5. So if P is 0.5, Q is 0.5, their sum is equal to 1. So at that point, variance is maximum. At that point, variance is maximum. So what is the maximum value of variance? So we will write n, the value of p is half, value of q is half. So that is why it becomes n by 4. So n by 4 is the maximum possible value of variance. Variance cannot exceed n upon 4. चाहे आप कुछ भी वैल्यू ले लें, variance cannot exceed n upon 4. Okay. So always mean is greater, and what is the maximum value of variance? It is n by 4. Now Ritu is having one doubt. Ritu says, पहले अगर आप फॉर्मूला देखें तो वेरिएंस का फॉर्मूला कैसे बना? NPQ. That means NP is basically mean, एंड मीन को हम क्यू से मल्टीप्लाई कर रहे हैं, और किसी भी नंबर को अगर हम मल्टीप्लाई करते हैं तो रिजल्ट तो इंक्रीज हो जाता है, बट यहाँ वेरिएंस कम कैसे हो रहा है? यस, so here we have to understand the value of q is always less than 1. तो कोई भी ऐसा नंबर जो कि 1 से छोटा है और अगर आप उसको मल्टीप्लाई करेंगे, the result will get reduced. For example, the NP is 10 and Q is half. तो जैसे ही आपने हाफ से मल्टीप्लाई किया, the result gets reduced to 5. रिजल्ट 10 से कहां पर पहुंच गया? 5 पे आ गया. ओके, सो जब भी कोई ऐसा नंबर है जो 1 से छोटा है, इट विल गिव द रिवर्स इफेक्ट. If you have to divide 10 divide by 1 by 2, what will happen? Normally डिवीजन करने से नंबर डिक्रीज होता है, बट जब आप हाफ से डिवाइड करेंगे तो नंबर विल इंक्रीज. Okay, so this reverse thing happens when the number is less than 1. Similarly, जब भी हम स्क्वायर रूट करते हैं, वैल्यू डिक्रीजेस. लाइक रूट ऑफ 4 is 2, रूट ऑफ 9 is 3. बट अगर कोई ऐसा नंबर है जो कि 1 से छोटा है, like 0.75, and if you are doing the square root, it will increase. So 0.75 का square root we can check, you will get 0.8 something. So it will increase. तो जब भी कोई नंबर 1 से छोटा होगा, that will give the reverse. Okay, understood? So 2 points we have to remember here. One is mean is greater than variance, and second one is what is the maximum value of variance? It will be n upon 4. And when it will happen? When p and q both are equal, that is 0.5. Then comes the next property, which is known as additive property of binomial distribution. Additive property of binomial distribution. So what is that? The first statement says x follows binomial distribution whose parameters are n1, p. So n1 and p, these are the two parameters. Similarly, y also follows binomial distribution with parameter n2, p. It is not 21, it is n2, p. Okay, it's not 21. So if x follows binomial distribution, y follows binomial distribution, then their addition, their sum will also follow binomial distribution. So therefore, we will write x plus y follows binomial distribution with parameters n1 plus n2, p. n1 plus n2, p. Okay. So Ritu says my doubt is clear. That's great. So simply you have to remember this third property. If x follows binomial distribution, y follows, then their sum will also follow the binomial distribution. Okay, and what will be the new parameter? It will be n1 plus n2, p. So let's take the numerical example. X follows binomial distribution with n1 is 12 and p is 0.5. Similarly, y follows binomial distribution with parameter 10, 0.5. Therefore, x plus y will also follow binomial distribution with the parameter n1 plus n2, p. So 10 plus 12 becomes 22, 0.5. Okay. Now, the next thing is application. Application of binomial distribution. So where binomial distribution is used, what are the basic conditions? So it is applicable when the trials are independent of each other. Only ऐसे cases में apply होगा जहां पर trials एक दूसरे को affect नहीं करें. Like in case of a coin, पहली बार head आया तो second time क्या आएगा, कुछ भी आ सकता है, anything can happen. So those events are independent. Then और कहाँ apply होगा when there are only two outcomes. One is success and another is failure. No third outcome is possible. So it is applied in tossing experiments, some sampling inspections, whether we have to accept the sample or we have to reject the sample. In those cases also we can use. And some similar kind of experiments. Okay. So now 16.1, this example you can easily solve now because this pattern we have covered. So let us understand the question first. A coin is tossed 10 times. So what is 10? It is n. Assuming the coin to be unbiased, it is a normal coin. What is the probability of getting 4 heads? Now, since 4 heads is there, so what will be x? X will be 4. What about P and Q? Because we are getting head, so P will be half, and the failure will also be half, that is 1 by 2. If it is at least 4 heads, then how you will solve? Now, at least 4 heads, that means X will be 4 or more than 4. So 4, 5, 6, 7, and so on, up to 10. So X can go up to n. It cannot exceed more than 10. Because if we are tossing 10 coins, we cannot get 11 heads. Okay, so maximum number of heads will be 10. So X will be from 4 to 10. Now, if you see that, it will become a bit lengthy because we have to solve 4, 5, 6, 7, 8, 9, 10. So 7 things you have to solve. So if you have to do this a bit shorter, then what can be done? ऐसा x आपको लेना है जो इसमें इंक्लूडेड नहीं है. सो वन थिंग कैन बी डन, यू कैन रिमूव 1 minus probability of x equal to, now 0 is not covered, 1, 2 and 3, these are not covered, so you can do 1 minus probability of 0 to 3. You will get the same answer, but it will be a better method, a shorter method. And then comes the third part, which is at most 3 heads. So x will be 0, 1, 2, 3. At most means maximum. So maximum 3 heads. So 0, 1, 2, and 3. Okay. Now you can easily apply the formula and get your results. Okay. So let's come on the second one, 16.2. If 15 dates are selected at random, what is the probability of getting 2 Sundays? So always write down the first 4 values. The 4 values which are required is N, X, P, and then Q. So 15 dates are selected. So this experiment is having n equal to 15. Okay. So what is the probability of getting 2 Sundays? 2 denotes x. So 2 Sundays. Since we require Sunday, what is the probability of getting Sunday in a week? So in a week, there are 7 days. And out of those 7, what is the probability of getting Sunday? It is 1 by 7. And failure, not getting Sunday. So chances of not getting Sunday are 6 by 7. So these are the 4 values N, X, P, Q. Now you can apply this and get the result. So therefore, the required probability of 2 Sundays will be 15C2, 1 by 7 to the power of 2, and 6 by 7 to the power of 13, that is 15 minus 2. So now you can multiply, divide, and get your result. Okay. So any doubt till here, let me know. So are you finding it easy or difficult? This chapter seems to be easy or difficult. So all these powers you have to calculate on your calculator. So 15C2, you can easily simplify 15 into 14 by 2, then 1 by 49, and then first divide 6 upon 7 and then find the power. Okay, first divide them and then find the power. So Manish is clear, Nikita says crystal clear, Manish says very easy. Then Miss, if there's some Azmi says, please explain NPX part. Okay, I think you have not done combination chapter, permutation and combination. So it's better you can go through that lecture first and then you try to solve this. Because without doing that, you will not be able to solve this combination. Okay, Miss Azmi. Then Nikita says easy, Swati says clear, Lisa says easy. Great, perfect. So now let's move on the next question. So you have to make a habit in math or stats, like what is given in the question, write those things first, and then see the requirement of the question. So let us try to extract the figures from example number 3. The incidence of occupational disease in an industry is such that the workmen have 10% chance of suffering it. So if P denotes the chances of suffering, so P is 10%. 10%, that is 0.1, you can say this is the probability of suffering. So what will be the probability of not suffering? 1 minus 0.1, you can say, that is 0.9. This is Q. What is the probability that out of 5 workmen, so N is equal to 5. 3 or more will contact the disease. 3 or more will contact the disease. So X will be how much? So X will be 3, 4, and 5 because 3 or more is written here. Therefore, X will be 3, 4, and 5. Now you can simplify. So Mr. Khan is clear, Ritu says very easy, Dimple says easy, Sakti saying easy. Sindhu is asking the weightage of the chapter. Weightage is 4 to 5 marks, Miss Sindhu. Then Ritu says your teaching technique make everything easier. That's great. My pleasure. Perfect. So you have find all these values. Now simplify. Therefore, the required probability will be Px equal to 3 plus Px equal to 4 plus Px equal to 5. This we have to simplify. So what is Px equal to 3? 5 C3, then 0.1 to the power of 3 and 0.9 to the power of 2 plus 5C4, 0.1 to the power of 4 and 0.9 to the power of 1 plus 5C5, 0.1 to the power of 5 and 0.9 to the power of 0. So we have to add all these three and get the results. Okay. Then Aditya says, can we do 1 minus T none? Yes, you can do that also. If you want to do that way, So it will be 1 minus p x equal to 0, 1, and 2. So in both the cases, we have to solve three calculations. Here, 3, 4, 5. Three calculations. Here, 0, 1, 2, three calculations. So it will be same efforts. Same efforts will be used. So you can use any one. So those who are unable to solve combination, go through please with permutation and combination chapter first. Okay. So all the lectures are available on the application. So you can go with that. And if you need additional questions, additional lectures, then you can go through Students Clinic app. You will get the additional things. Okay. Now the fourth one, example 16.4. Example number 16.4. Find the probability of success for the binomial distribution satisfying the following relations and having the parameter n as 6. So parameter n is 6 and this relation is given. What you have to find the probability of success. That means we have to find small p. N is given as 6. Q is also not available. So what is available? The relationship. 4 times of probability x equal to 4 equals p x equal to 2. Now, let's apply the values. 4. Now, we have to simply reuse the formula of binomial distribution. So 6 p 4 because x is 4. Then p to the power of 4 and q to the power of 2. Since p and q are not available, we are writing p and q as it is. Then px equal to 2. So 62 p to the power of 2 and q to the power of 4. So first of all, we have to substitute the given values. So we have substituted the values. Now in combination, we have done that 6c4 is equal to 6c2. This we had done. So since these two are equal, we can cancel them. Then p square will be cancelled. Q square will be cancelled. So what is left? 4p square is equal to q square. This is left. Now we can take square root on both the sides. Square root on both the sides. So square root of 4 is 2. P square is P. Q square is Q. Okay. So we have done till here. Then what is the value of P? P will be 1. What will be the value of Q? Q can be written as 1 minus P. So therefore, it will be 3P equal to 1 and P becomes 1 upon 3. So 1 by 3 becomes the value. Okay. So in this way, we can calculate the probability of success. If you require failure, you can do 1 minus P. You will get the probability of failure. Then Ritu is asking any calculator tricks available. See, all these calculations can be done on your calculator. So using M plus M minus tricks, MRC buttons, you can simply do all these calculations on your calculator. But I will always recommend you first write all these things with your hand in your notebook. Because if you are having the writing ability, then only you will be able to simplify, you will be able to solve all these calculations on your mind using your calculator. तो अगर आपको ये सारी चीजें हाथ से की हुई होगी, then it will be better. आप उसको orally जल्दी से कर पाएंगे. All right. Then the next thing, 16.5. Find binomial distribution for which mean and standard deviation are 6 and 2 respectively. So question is talking about find binomial distribution. So here we have to find the distribution for which mean is given, standard deviation is given. So let's write that. Mean is denoted by NP and mean is equal to 6. Then what is given? Standard deviation. Standard deviation is root of NPQ and this is equal to 2. So if root NPQ is 2, so what will be NPQ? Squaring both sides, it will become 4. So NPQ is equal to 4, NP is equal to 6. Now, you can substitute the value of NP here. We can substitute the value of NP. So it will become 6Q equal to 4. Therefore, Q will be 4 by 6 or you can say 2 by 3. This will be the value of Q. If Q is 2 by 3, what will be P? P will be 1 by 3. So Q is 2 by 3, P is 1 by 3. So this is the first step in which we have to calculate P and Q. Now, after this, you have to calculate N. So how to calculate N? So we know that mean is 6. And P we have computed how much? 1 by 3. So N into 1 by 3 is 6. So therefore, N will be 18. So N is 18. And now you have to find the distribution. So whenever question says find distribution, it is written in the form of Q plus P whole to the power of N. This is the format. This is the format. Q plus P whole to the power of N. So you will write Q first, 2 by 3 plus 1 by 3 is P whole to the power of 18. So this will be your final answer. Okay. So in this way, we present the binomial distribution. Done. So 2 by 3 plus 1 by 3 whole to the power of 18. Then this type of question we have done. So 6 questions are included in this. Like you have to solve different cases. When x is 0, when x is 1, when x is 2. So you have to solve a question 6 times. So for different value of x, you have to calculate. So one by one, we have to put the values and get the result. But this complete table question cannot come in MCQ pattern. This is simply for kind of example they have given. Now, 7th one. 6 coins are tossed 512 times. Now, 6 coins are tossed 512 times. Find the expected frequency of heads. So what is the requirement? We require expected frequency. So probability is not asked. What is the final answer required is expected frequencies. Also compute the mean and standard deviation of the number of heads. So we require mean, we require standard deviation. So these 3 things are required. So let's begin. So first of all, let's see how to get the figures. How to calculate mean. So to calculate mean, the formula is n into p, small n, and multiply by p. So what is n here? So 6 points we are talking. So n is 6. And what is the probability of success? Since we have to find heads, so p will be half. So 6 into half. Mean will be 3. Mean is 3. What will be the standard deviation? It is NPQ. If P is half, Q is also half. So it will be 6 into half into half. That is 3 by 2. 3 by 2. This is standard deviation. And now you have to calculate expected frequency of heads. So expected frequencies is calculated as capital N multiplied by the probability. So first we will write all the different possible cases, like heads can be 0, it can be 1 head, 2 head, 3, 4, 5 or 6 head. Now what are the chances of getting 0 head? For 0 head is 1 by 64, then 6 by 64. This all you have to calculate using that formula. Which formula? NCX p to the power of x q to the power of n minus x. So this frequency we have to calculate. This probability we have to calculate. So it is simply probability. Then expected frequency. So for expected frequency, we have to multiply n with p. What is n? It is 512. 512 because 6 points are tossed. These 6 points are tossed 512 times. This 512 is basically capital N and these 6 is small n. So whenever we have to calculate frequency, use capital N. So here we are doing capital N multiplied by the probability. So how is 8 coming? 512 multiplied by 1 upon 64. Then 512 multiplied by 6 upon 64. So in this way, we are getting all these frequencies. And the sum of frequency will be of course equal to 512. 512. Okay. Yes, Tanvi says as these root of NPQ, she is correct. You have to write the square root on the top. Correct will be root of 3 by 2. Yes, Tanvi, you are 100% correct. Okay. So in this way, you can calculate all the frequencies. Then mean and SD we have already calculated using the shortcut method. And here you are given the formula which we use in expected value concept. In expected value also, we have computed standard deviation. So formula was expected value of x square minus expected value of x whole square and then square root. This was the formula for standard deviation. So here this formula is used. So this will also give the same result, but we have used the shortcut one, root NPQ. So our answer is root 3 by 2, or you can write root 1.5. That is 1.22 is the answer. Okay. So such lengthy question, of course, cannot come in exam. Some part of this question can come. Like only you have to calculate mean or standard deviation or variance, but this complete table cannot come. Okay, because we are having MCQ pattern. So before moving further, let's take a break of 5 minutes and then we will be continuing with the questions. Okay, so 5 minutes break. So welcome back, guys. So we have completed till 16.7 example, and now let us continue with some more 16.8. Yes, this is a language-based question. So how to interpret this and how to extract the figures from this is very much important. So an experiment succeeds, right, as after it fails. So three times there is a success, and after there is a failure. Three success and then one failure. If the experiment is repeated five times, what is the probability of having no success at all? No success at all. So here, first of all, the ratio of success and failure is 3 is to 1. 3 is to 1. Therefore, we will write probability will be 3 upon 4 and Q will be 1 upon 4. This is P and Q. If the experiment is repeated 5 times, so N is equal to 5. Then what is the probability of having no success? That means X is equal to 0 because there is no success. All right. So all these are the values. Now you can substitute and get the results. So probability equal to 5 C0, 3 by 4 to the power of 0, and then 1 by 4 to the power of 5. So you will get the answer 1 by 4 whole to the power of 5, or you will write 1 upon 1024. This will become your answer. Okay. Then Aditya Darshan says, please repeat example 7. Okay, no, don't worry. So let's repeat this. Example number 7. See, in example number 7, it says 6 coins are tossed. So we are having 1, 2, 3, 4, 5, 6. So N is equal to 6. These 6 coins are tossed. How many times they are tossed? They are tossed 512 times. So this 512 is basically capital N. So this is 512. Now, what is requirement? Our requirement is about heads. So P will be half. Q will also be half. What about X? So X will be, since we have to compute all the frequencies, so we have to take X as 0, 1, 2, and so on up to 6. So you have to form the complete table. So if X is 0, what will be the probability of X? So we will be solving this. 6C0, 1 by 2 to the power of 0, and by 1 by 2 to the power of 6. What you are getting 1 by 64. Now we require frequency. So frequency will be N 512 multiplied by probability. It will become 8. So this 8 is your frequency. Then if X is equal to 1, then you will write 6C1, 1 by 2 to the power of 1, and 1 by 2 to the power of 5. Overall, it will be 6. So 6 by 64. So 512 multiplied by 6 upon 64, you will get 48. Similarly, if X is 2, then you will write 6C2, 1 by 2 to the power of 6. So 15 upon 64. So how much you will get? 512 into 15 upon 64. So 15 into 8 becomes 120. So in this way, you can get all the frequencies of 3, 4, 5, 6. Okay. So this is the tabular proof. Then you require mean. So formula for mean was N multiplied by P. So what is N? So we are tossing 6 times. So N is 6. Probability of getting head is half. So mean you will get 3. Then what is standard deviation? It is square root of NPQ. So we will be writing 6 into half into half. So it will be root of 1.5, or you can say 1.22. Okay. So Manisha is asking about the table. In exams, you don't have to prepare this complete table because all these at one shot cannot be asked. You have to simply do the calculations on your calculator. That's very easy. It will take 10 seconds to solve. Okay, so no need to form the table. So 7th and 8th example we have covered. Now let's come on the next one. What is the mode of distribution for which mean is 10 and standard deviation are root 5? Yes, so this is the calculation of mode. So how do we calculate mode? So let us write the formula for calculation of mode. Calculation of mode in binomial distribution. The first point says if n plus 1 into p is a whole number like k, then then mode is equal to k comma k minus 1. K comma k minus 1. And second, if n plus 1 into p is not a whole number. If it is not a whole number, that means it will be in fraction decimal. So in that case, mode will be equal to k. Mode will be equal to k. So let's understand. Let's say if n plus 1 into p, this is equal to 12.2. 12.2. So it is in decimal. So what we have to do, ignore this decimal part, remove 0.2. So mode will be 12. If it is 13.6, then also remove 0.6, mode will be 13. If n plus 1 into p is, let's say, 10, then mode will be 10 and 10 minus 1, that is 9. So two modes will be there. One is k, other is k minus 1. But two modes will be there when n plus 1 into p is a whole number. So let us take it another way. If n is 10, p is half, then n plus 1 into p. So 10 plus 1 into half is 11 by 2, or you can say 5.5. 11 upon 2 or 5.5. So this is not a whole number. This is into fraction or decimal. So remove this decimal part. So mode will be equal to 5. Mode will be equal to 5. If n is 9, probability is half. Then what will happen? Then you will write 9 plus 1 into half. That is 5. So now this time it's a whole number. So mode will be 5 and 5 minus 1, that is 4. So 5 and 4 will become the mode. Okay. Ms. Khan is asking, in exam we use calculator. Yes, calculator is allowed in examination. You can do all your calculations using that calculator. Okay. So now let's move on 16.9. It says, what is the mode if mean is 10? So mean, that is n into p, is equal to 10. And standard deviation, that is root NPQ, is equal to root 5. On squaring both sides, we see that NPQ is 5. NPQ is 5. So you can replace the value of NP here. So 10Q is equal to 5. Therefore, Q will be half. Q will be half. If Q is half, then of course P will also be half. So N and P we have computed. Now, what we require? N. N we require, so we can use this formula. N into half equal to 10. Therefore, N is 20. N is also 20. Now, for mode, what we have to do? N plus 1 into P. So, how much is coming? 10.5. So, it is into decimal. So, remove this after decimal portion. So, mode will be 10. Mode is 10. So, in this way, you can easily calculate mode. Now, the 10th one. If x and y are two independent binomial variables with parameter 6.5. So these are the two parameters. So what are the two parameters? One is n, there is p. So n is 6, p is half. Then other side, n is 4 and p is half. So we can say n1, n2, and probability should be same. So these are the two independent binomial variable. One is denoted by x, other is denoted by y. Then what will be the probability of x plus y greater than or equal to 1? This we have to compute. Okay, so we have to see what is x plus y. So what will be the parameters of x plus y? The parameters for x plus y will be, and we can add 6 plus 4, it will become 10, and probability will be half. So 10 and half will become the parameters. So we can write here, number of trials will be 10, then probability of success is half, probability of failure is also half, and what you can say, x is greater than equal to 1. Greater than equal to 1 means 1, 2, 3, and so on, and so on. But for shortcut method, what we can do, probability equal to 1 minus px equal to 0. So we can use this and solve the shortcut manner. So 1 minus 10 is 0, 1 by 2 to the power of 0, and 1 by 2 to the power of 10. You will get 1 minus 1023 upon 1024. 1 minus 1 by 21024. So this will become your final answer. Okay. So in this question, basically, first of all, we have to calculate px plus y. So x plus y will be n will become 10, and probability will be half. So after getting the new parameters, you have to find out the value of x. So the value of x was greater than equal to 1. So 1, 2, 3, and so on up to 10. But for simplicity, we have to do 1 minus px equal to 0. Okay. So from the illustration, we have completed about the binomials. Then let's move on back questions. Back questions. Set A. Now, second one, the probability distribution may be discrete or continuous. It can be any one, A or B. So option number D. An important discrete probability distribution. So which is the part discrete? We know out of all these four, position is discrete. So we have to select position, which is important, continuous probability distribution. So continuous we have to find. So continuous is normal distribution. Option number D. Okay. Then the fifth one, parameter is a characteristic of. So this is basically based on population. So parameter basically it's a characteristic of population. Then six, an example of parameter. What is the example of parameter? So parameter is basically the thing which denotes the population, the whole of the thing which is considered. Let's say there are 100 observations and we have to find out the result of all the 100 observations, but we are short of time. So what we can do, we can take a sample of 10 units. If 10 units are okay, then we say that the result is correct. If 10 are having some errors, then we may reject the whole lot. So this 10 is basically the sample, and this 100 basically denotes the whole of the things which is under consideration. That is, it is parameter. Okay. Then the example of parameter is, so what is the example of parameter? The example is basically the population mean. So whenever we are talking about the whole of the thing, the population, it is parameter. Option B. Seventh one, a trial is an attempt. So what is the meaning of trial? To make something possible or to make something impossible, prosecute an offender in a court of law, or produce an outcome which is neither certain nor impossible. So trial means any experiment. कोई भी experiment जो हम conduct करते हैं, whether it can be a success or whether it can be a failure, it may be possible, it may be impossible. So the correct option will be D. Okay. Eighth one. The important characteristic of Bernoulli trial. Bernoulli means binomial we are talking about. So for binomial, what are the basic conditions? What are the basic characteristics? This we have to find out. So each trial is associated with just two possible outcomes. Yes, this was the characteristic. This we have covered. Then trials are independent. Yes, this is also correct. Third one says trials are infinite. Yes, they are infinite or not? No, they must be finite. Trials must be finite in case of binomial. So C is incorrect. So we have to select option number D, both A and B. Both A and B. So Dimple has given the answer, Ritu has given, and Surya Kumari. Great. Then the formula for binomial distributions probability will be NCX p to the power of x and q to the power of n minus x. That is option number B. So B will be correct. Then, if x is a binomial variable with parameters n and p, then x can assume value. So x की value क्या होगी in case of binomial distribution? Of course, x can be 0, it can be 1, it can be 2, up to it can be n. Up to n. From 0 to n, it can have any value and it must be a whole number. Therefore, the correct option is C. Any whole number between 0 and n and both inclusive. Both inclusive. So 10th correct option will be C. 11. Binomial distribution is never symmetrical or never positively skewed, never negatively skewed, and then symmetrical. So what is the meaning of this symmetrical and asymmetrical? Symmetrical means when we are having a curve whose rise and falls are equal. जिस रेट से फ्रीक्वेंसी इंक्रीज होती है उसी रेट से फ्रीक्वेंसी डिक्रीज भी होती है. दोनों साइड का जो एरिया है, the area on both the sides is equal. So 50% area is on left hand side and 50% area is on the right hand side. So such kind of distribution is known as symmetrical distribution. So this symmetrical distribution will be only when P is equal to Q, that is 0.5. तो जब P and Q दोनों इक्वल होंगे तभी हम बोलेंगे कि डिस्ट्रीब्यूशन कैसा है, सिमेट्रिकल है. दैट मींस दोनों साइड एरिया इक्वल है. जिस रेट से फ्रीक्वेंसी इंक्रीज होती है उसी रेट से फ्रीक्वेंसी डिक्रीज भी होगी. देयरफॉर द करेक्ट ऑप्शन विल बी डी. करेक्ट ऑप्शन विल बी डी. ओके. Then 12th. Now what is the 12th one? The mean of binomial distribution with parameter n and p. So what is the formula for mean? Of course it is n into p. N multiplied by p. Then 13. The variance of binomial distribution with parameter n and p is. So we have to calculate the variance. So how to calculate the variance? We have done the formula. It is NPQ. But NPQ is not given in the option. Options are a bit modified. We have to see which modified option is correct. So let's check. In place of P, of course, we can write 1 minus Q. P is basically 1 minus Q. Therefore, the correct option will be C, N, Q, 1 minus Q. C option is the perfect. Okay. 14. An example of biparametric discrete probability distribution. Now, what is biparametric? Bi means 2 and parametric means parameters. So 2 parameters. So we have done that in binomial distribution. There are 2 parameters. One is n, other is p. So binomial distribution is basically biparametric discrete probability distribution. Okay. Then 15. For a binomial distribution, mean and mode. So it's talking about mean and mode. Will they be equal or not? So mean and mode will be equal when the distribution is symmetrical. When the distribution is symmetrical. That means when P is equal to Q, that is 0.5. At that point of time, mean is equal to median is equal to mode. All these three will be equal. All these three will be equal. Okay. So this is the case when mean, median, and mode are equal. So both the sides, the area is equal, 50% on left hand side, 50% on the right hand side. In case the area is different on both the sides, let's say this is having 60% area on right, 40% on left. So we say that this distribution is skewed. And this is skewed more towards positive sides. So it is positively skewed. If the left-hand side area is more, then we say that it is negatively skewed. So skewed means किस तरफ area ज़्यादा है, किस तरफ frequency ज़्यादा है, that will be skewed. If on both the sides there is equal frequency, then it will be symmetric. Okay. So for 15th, what we have to tick, we can select option number C. Mean and mode are equal when Q is 0.5. 16. The mean of binomial distribution. Now, what is the mean of binomial distribution? It is less than or more than or equal to variance. So we know that mean is always more than variance. So option number A. Mean is greater than variance. Then for binomial distribution, there may be one mode or two mode. So we have covered this. There can be one mode, there can be two mode. It depends whether it is a whole number or not a whole number. So answer will be option D. It can be either one mode or two mode. Okay. Next, the maximum value of variance of binomial distribution with parameter n and p is. So maximum value of variance, we know it is n upon 4. Now, this is again a theoretical question. The method usually applied for fitting a binomial distribution. The name of the method. The name of the method is simply known as. Which one is correct? Question number 19. Let me know. कौन सा option correct होगा? Method used for binomial distribution. The name of the method is method of moments, or you can say moments method. The name of the method is moments. So from 20, the questions are based on other distributions. Then let's move on set B. Set B says, what is the standard deviation of the number of recoveries among 48 patients? So what is 48? It is N. When the probability of recovering is 0.75, recovery, so P is 0.75. What will be Q? It will be 0.25. And now we require a standard deviation. So standard deviation is root of NPQ. So 48 into 0.75, you can write 3 by 4. 0.25, you can write 1 by 4. And now let's simplify. We are getting 3. So standard deviation is equal to 3. Okay. Perfect. Any doubt in this? So everything was given NPQ, and then we have to calculate the standard deviation. So the next one. Second, x is a binomial variable with n equal to 20. So this time n is given. What is the mean of x? Mean we have to calculate if x is symmetric. X is symmetric. So we know that symmetric means P is equal to Q. That is 0.5. So for the calculation of mean, it is 20 into 0.5. That is 10. Option number B. Okay, so Shruti says understood, no doubt. Simple says clear. Priyanka says no doubt. Great. Then the third one, x follows binomial distribution with parameter n comma p. Then what will be the greatest value of variance of x? So greatest value you have to find out. So it will be n upon 4. So variance is 16 by 4. That is 4. Option number B. Option B is correct. Okay. Fourth one. If x is a binomial variate with parameter 15 and 1 by 3, then we have to find out the mode. So n plus 1 into p. 15 plus 1 into 1 by 3. How much you are getting? 5.33. So since it is into decimal, remove the decimal portion. Answer will be 5. Now fifth one. Fifth one you can try now and let me know the answer. You have to solve this within a minute. So you are having 1 minute. I'm waiting for you and get the answer. Question number 5. Mean is 3. And SD is 1.5. Find N. Sindhu has given the answer option number D. Okay. What about others? This pattern we have covered. Mean is 3. So NP is 3. Standard deviation root NPQ is 1.5. Now squaring both the sides, you will get NPQ equal to 1.5 square, that is 2.25. And you can replace NP with 3. Therefore, Q will be 2.25 upon 3. Upon 3, it will become 3 by 4. So Q is 3 by 4, P is 1 by 4. So from here, you will get that N into 1 by 4 is 3. So N will be equal to 12. N will be equal to 10. Okay. So option number D is correct. So Ms. Anna has given the answer. Dimple, Shruti, Manish, Swati, Manisha, Shriparan, Swati, great. So 12 is the answer. Sixth one. This we have done in the beginning of the session. 6 points are tossed, and what is the probability of getting 3 heads? So this we have done in the beginning. Then seventh one. Yes, seventh you can try now. That's a good question. You can try this. After that, I will be discussing. So if overall percentage of success in exam is 60, so success percentage is given. What is the probability that out of group of 4 students, at least one has passed? At least one passed the exam. It's easy. Shreya has given option C, option D. Okay. Let's wait for others also. So in this, what are the given values? We can write. Overall percentage of success. That means it is P. 60%, 0.6. Therefore, failure will be 0.4. Then what is the probability that out of 4 students, so N is equal to 4, at least one passed? So X will be at least 1. So 1, 2, 3, 4. But what is the shortcut? We will write 1 minus none. So 1 minus X equal to 0. This we have to solve. So 1 minus 4C0, 0.6 to the power of 0, and 0.4 to the power of 4. 0.4 to the power of 4. So 1 minus 0.4 to the power of 4, you will get 0.9744. So this will be your answer. The 9744. Option number B. So in this way, you can easily get your results. Then Nabil is asking about some additional previous questions. Okay, so you can download the application Students Clinic, and there you will find the additional questions. Okay, you will get everything. So you can get the application Students Clinic. Eighth one. What is the probability of making 3 correct guesses in 5 true false answer type question? So what you have to do? 3 correct guesses in 5 true false answer type questions. So since there are 5 questions, so n will be equal to 5. N is equal to 5. We have to make 3 correct guesses. So x will be 3. Okay. Then true false answer type questions. So probability of giving true answer is half and false answer is also half. So it is half and half. Now what to do? Now apply the formula and get the result. So 6t and 5t3, 1 by 2 to the power of 3 and 1 by 2 to the power of 2. So you will get 5 into 4 upon 2 multiplied by 1 by 2 to the power of 5. So 10 upon 32, or you will get 5 by 16. 5 by 16. So 0.3125. This will be your answer. Option number A. Yes, the dimple and reticulus is the answer. Option number A. This is correct. So from set B also, we have covered all the questions. Now let's take some questions from set C also. The first one. If it is known that the probability of a missile hitting the target is 1 by 8, missile hitting the target is 1 by 8. So what is the probability that out of 10 missiles fired, at least 2 will hit the target? So let's take the probability of hitting is 1 by 8. So probability of not hitting becomes 7 by 8. Now, how many missiles are fired? So n is equal to 10. And x, we require at least 2 hit the target. So 2, 3, 4, and so on up to 10. So since it is at least 2, shortcut is there. So we will be writing 1 minus probability of x 0, 1. So if we exclude 0 and 1, then we will get the answer. So 1 minus. So first we will solve about 0. 10 C 0. 1 by 8 to the power of 0 and 7 by 8 to the power of 10. Plus 10 C 1. 1 by 8 to the power of 1 and 7 by 8 to the power of 9. Now you can simplify this and get the result. Okay. So easily you can do the multiplication, division, and get the result. So this is basically the first part. All right. So we have covered each and every questions of binomial distribution, each example we have taken, each set A, set B we have done, and let's do one or two more questions from set C, so that all lengthy questions are also covered here. So next we will try the second one. X is a binomial variable that times of px is equal to px equals 3. This is a relationship which is given. Mean of x is known to be 10 by 3. So 10 by 3 is the mean. What would be the probability that x assumes at most the value 2? So the maximum value is 2. Okay. So first of all, how to simplify this? You have to form the equation and get the result. So let's apply 2 px equal to 2 and px equal to 3. So from here, apply the formula n. So what is n here? N you don't know. Then nc2 p to the power of 2 and q to the power of n minus 2. Q to the power of n minus 2. It is equal to px equal to 3. So nc3 p to the power of 3 and then q to the power of n minus 3. Now you have to simplify this and get the result. So this becomes the first equation. Also, you know that mean is 10 by 3. So formula for mean, that is n into p, is 10 upon 3. It is 10 upon 3. So from these two equations, you have to simplify and get the value of n and p. And then you will get the result. So it's a bit a lengthy question and basically not relevant for our exams. Okay, but if you have to solve, you can simplify these equations and get the result. Now, let's take some more questions. Now, majority of questions are from Poisson and normal distribution, which we'll be covering in the next two sessions, our last two sessions. Okay. So all these are different. Then you can try the fourth one. Fourth one, if a random variable x follows binomial distribution, x follows binomial distribution with mean as 5 and satisfying the condition. So what will be the probability where px greater than equal to 1 upon x greater than 0? So this is given. So from here, mean is given and the relationship is given. So it is almost similar to the question number 2. So again, it's a very lengthy. Then Ritu is asking about the seventh one. Okay, let's see the seventh one. If in a binomial distribution is fitted to the following data, find the sum of expected frequencies of 2, 3, and 4. The value of x given is 2, 3, and 4. And you have to find out the sum of expected frequencies. So how to find the sum of expected frequencies? So first of all, calculate. You have to calculate n, or you can say frequency for x equal to 2, frequency for f2 plus f3 plus f4. So you have to solve here 3 times and then get the result. And then we have to get the result. So similar tabular questions we have covered, but again, tabular questions we are not supposed to answer because in exam the tabular question doesn't come. So in most of the chapters, set C questions are not much of relevance because they are very lengthy questions. But few questions will be there in Poisson and normal distribution that will be relevant, and then we have to do that. Okay. So let us summarize what we have covered from the summary section. So let's take out the summary section.
So, very
Yes. So here, this is the summary section. So probability distribution, or also known as continuous probability distribution, this is divided into two parts. One is binomial, one is basically discrete, another one is continuous. Discrete is divided into two parts, binomial and Poisson distribution, whereas continuous is having normal distribution. Then in case of binomial distribution, we have seen some of the conditions. First is there are n number of trials. Trials must be positive, then finite value and a whole number. It must be a whole number. Then the trials must be independent of each other. Then there are only two outcomes. Outcomes will be mutually exclusive and exhaustive. And the sum of probability should be equal to 1. So P plus Q is always equal to 1. So these were the four conditions. Then after that, we have seen the four formulas. One is the formula for probability, MCX, P to the power of X, Q to the power of N minus X, where value of X lies from 0 to N. And the sum of power is always equal to N. This is the power of P, this is power of Q. So X will get cancelled and you will get the result N. Okay. Then if X follows binomial distribution, Y follows binomial, then X plus Y will also follow binomial distribution. So all these we have covered. Then some formulas also we had done. The formula for mean. The formula for mean was N into P. Formula for variance was NPQ. And the formula for standard deviation was root of NPQ. So all these we have done today in our session. So I think we have covered each and every question, each and every variety from this topic, and hope you have understood very well. Any doubt, you can let me know. So our next session will be day after tomorrow, that is on Thursday. On Thursday, we will be covering Poisson distribution. So Poisson is also the part of discrete distribution. So we will complete that thing on Thursday. And after that, the last part will be their normal distribution, which we will be covering on Saturday. Okay. So Nikita says, thank you so much. Is understood. Great. So that's all for today, guys. So let's have the next session. Let's meet in the next session tomorrow. Till then, take care. Bye bye. See you soon.